All right, so on the back side, the quadratic formula here, we have, I don't know if we're going to need the calculator, so I'm going to get rid of that. We're going to put up here what the quadratic formula is. What I'm going to have you write again real quick is ax squared plus bx plus c equals 0. This is important. In order to use the quadratic formula, your equation must be equal to 0. Okay, that's the first thing you need to do in your problem is make sure you have your equation equal to 0. Once the equation is equal to 0, and you probably want to make sure it's in that order too, so you can easily recognize A, B, and C, then what you want to do is use quadratic formula. Here's the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Not asking you to memorize that. That is something that you'll be given on your quiz. We'll either have it up on the board or it'll be on the quiz. You just need to know how to use it and how to simplify it, how to put the values in and how to simplify it. Okay, now I teach the quadratic formula a little bit different than other teachers do. So I know you've probably had it before. A few years ago, I started doing it a little bit differently. I always simplify that square root of b squared minus 4ac first. And the reason why I do that is if you write the whole quadratic formula and then take a step to simplify it and find out what's in there, you're rewriting all of that stuff over and over and over again. You might have 3 steps, you're writing this whole thing over and over again. Where if you do this first, then you just plop that number into the quadratic formula, and you usually have like one more step after that. Okay, so let's take a look at what that's going to look like here. Has everybody got that quadratic formula written down? All right, so let's go all the way down, just in case we don't get time to get there, to make sure that we would know what to do first in a problem like example 4. Notice in example 4, it's not equal to 0. So the first thing you'd have to do is subtract that 14 over so that it's equal to 0. So the first thing we would do in example 4 is subtract that 14 over so that it's equal to 0. Now we know that A is 1, B is 4, and C is negative 14. C equals negative 14. All right, let's just continue on at this one, just so you can see what we would do from here. So the first thing, like I said, that I like to do is simplify b squared minus 4ac under that radical there. Okay. By the way, this thing has a name. I'm going to put it up here too. This b squared minus 4ac is called the discriminant. And the reason why they gave it a name is because it's pretty important. It tells us, number one, if we even have any real solutions, any numbers that are actually solutions in our real number system, and number two, how many solutions we actually have. Right? When we come down here, we put those values in. Okay, take the second to write this stuff in. Now, b squared, you can either write 4 squared, right, because that's b. What is 4 squared, though? Personally, I would do that right away. Most of these a, b, and c values are pretty small. They're less than 10, right? And I think you guys know your perfect square is up to 100. So, for example, 4 squared is 16. Then minus 4 times a is 1, and c is negative 14. All right, again, there's no shame in using a calculator for this. I'm just going to type it in exactly how I see it. 16 minus 4 times 1, which you know is not going to do anything. You don't even really need to put that in there, times negative 14. Make sure you use the negative symbol and not the subtraction symbol. And then when you hit enter, you get 72. Square root of 72. Okay? You could put those into parentheses if you wanted instead. 16 minus 4, and then in parentheses put 1, kind of the way that I wrote it there, and then in another parentheses negative 14. 72. Okay? But use your calculator, plug that all in, make sure you get that right value in there. All right, now what we don't want to do is take the square root of 72 and get a decimal on a calculator. We're going to do everything in exact form. All right, so this is why I put that 2.5 or 3 minute video on Classroom about simplifying these radicals. But here's a good example of it. I think in this class, actually, we did an example of this on Tuesday. Okay? What you're looking to do when you're simplifying a radical is find a perfect square that goes into the number. So you got to think of the number 72 and what factors it has. And you need to know what the perfect squares are. I'm going to write up here in our notes just a quick list of the perfect squares up to 100. That'd be 1, 4, 9, 16, 25, 36, 49, 64, 72, 81, and 100. Okay, so I can refer back to that list and just say, okay, which one of those goes into 72? 4 might, right? Because 2 goes into 72. 9 goes into 72, doesn't it? 8 times. Right? But you want the biggest number that goes into 72. There is a bigger number. It's 36. 36 times 2 is 72. So that might take a little playing around. Okay? So 72, you put the 36 first, and then you put what it's multiplied by to get 72. So it's almost like you're doing a little factoring there, just of a number. Not of a quadratic, don't worry. It's just of 72, you're factoring it to 36 and 2. And here's why we do that. What is the square root of 36? So what this simplifies to is 6 square roots of 2. Okay? Is everybody okay at that? Okay, so here's why I do this way. Had we done it the way that you'd learn in like Algebra 1 at the quadratic formula, we'd have written the quadratic formula now 1, 2, 3, 4, 5 times. We'd have written the whole thing 5 times if we would have shown all those steps. Because we did it this way, all we need to do now is take that 6 square roots of 2, and now we're going to plug it into the quadratic formula. So the quadratic formula is negative b. What is b in this problem? 4, so negative 4 plus or minus. Now here's where the work that we did pays off. 6 square roots of 2 goes right there. Okay, and this might get a little messy, but if you want to do something like that, that's where that came from. In the denominator, what is the denominator of the quadratic formula? 2a, right? So what is 2a? 2. All right, so 2.
How do you know it's 2?
What's 2? Because in the quadratic formula, in the denominator, it's 2a, right?
Yeah.
What's a in our problem?
Oh, 1.
1, so 2 times 1. All right, good. Ask questions. That's good. All right, so sometimes we can simplify the quadratic formula. This is a case that we can. If all 3 of these spots, that spot, and that spot, okay, maybe lightly circle them or something. If you can get a common factor divided out of all of those, which we can here, we can divide all those by 2. That will simplify your answer. Okay, so we're going to divide all 3 of those numbers that I have highlighted there by 2. So x is going to equal negative 2 plus or minus 3 square roots of 2. Okay, it doesn't affect what's in that radical. And that's all over what now? 1. Because we divided all of those by 2. Now it has to be common to all of those, all 3 of those. Now we don't really need it over 1. So I'm going to just take one more step to write this. And you could have gone right to this. I didn't want to do that in this example though. But that's what your final answer is going to be. Okay, now we wrote everything there because it's an example. You probably could skip maybe a step or 2 there. You probably could skip, that step right there. It's not always going to be that lengthy looking. But it is one of the longer processes we use. All right. So how about example 5?
Gotta subtract the negative years.
Okay. Add it, right? Because we're going to move this over to this other side here. So we have 3x squared. Make sure you put it in front because it's the x squared term. And then we have minus 4x plus 5 equals 0. Okay, now, yeah, this would be a good one to do here. So let's do this b squared minus 4ac thing first. Okay, now I'm not going to write b squared minus 4ac. Oh, maybe I'll just write it over here because you have it on top of your sheet that you can refer back to, right? I'm just going to put it right there. Okay, what would b squared be here? Well, b is what? So it'd be 16. Now here's the thing. This is why I would definitely do this in your head. Because if you type -4 in your calculator, many of you have done this year, if you don't put parentheses, it tells you -16, doesn't it? It's not -16 though. It's +16. So when you know that, I'm just, excuse me, I'm just going to write here that A is 3, B is -4, and C is 5. When you know that B squared is 16, write it. You don't have to worry about it anymore. So you have 16 minus 4 times A. This time A is 3 times C, which is 5. We good at this so far? Okay. All right. So now let's find out what I'm going to just do this right on my calculator. 16 minus 4 times 3 times 5. Notice I'm not typing in that big radical. I don't care about that right now because we're going to have to simplify it anyways. Don't do anything with the radical in your calculator. Okay. And I got -44. All right. So just write this. The square root of -44. All right. This is why I wanted to finish through this one here. Because what I'm having you guys do right now is stop right here. Can you take the square root of a negative? No, not in our real number system. There's a fun new number system we'll learn about at some point in time, maybe in here, maybe in the next class, called the imaginary number system. Right now, you just stop and say there are no real solutions. I'd even be okay with you guys doing this. Okay, either one of those would be totally fine. All right, we got 3 minutes left here. When are you guys packing up? 8:05. You can run, but you can't hide from it. All right, let's go back. Let's go up to example 3 here. Let's just calculate b squared minus 4ac. I just want to get one more of those in here. All right, what's b squared in this one? What's b squared though? Yes. 25. Oh, I thought you said -5. Sorry.
No, I
My
said
bad.
negative.
All right, so a is 2, b is -5, therefore b squared is at 25, c is -4. So you got 25 minus 4 times a times c. Okay, so we're going to do 25 minus 4 times 2 times -4. It's okay to type it in like that, or put them in parentheses. 57. 57 has no perfect square factors. So you can just plop it into the quadratic formula. Quadratic formula says -b. Well, that would just be 5. Opposite of b is 5 then. Plus or minus, and then that guy goes right there. And then the denominator is 2 times a. What's 2 times a? 4. You're done. I knew we could fit one more in there. All right, we're going to go to example 1 here. And first make sure that it's equal to 0. It is, right? We're good to go. So now you want to know what A, B, and C are. You don't have to write this if you don't want to. I think for some of us it's not a bad idea to stay organized by doing this. And then it kind of makes you think about what those values are right away. You recognize if things are negative or not. All right, now instead of writing down that whole big ugly quadratic formula, what I'd like you to do is just write the square root of, let's just, since I don't have it visible on screen, I'm going to write that. Okay, not that you would have to do that in every problem. You could go right to putting the numbers in. Okay, but here's one of my suggestions to you. What's b in this problem? 3. Do you know what 3 squared is? 9, right? Don't type in your calculator then 3 squared. Just put 9 here. All right. And then take the second to actually write 4 times whatever a is times whatever c is. Now, if you want to just straight up plug that in your calculator, I have no problem with that. All right. In fact, let's do that. We got 9. Don't worry about the square root. Just find the stuff underneath it. So it's 9. Do you see what I messed up already? Yeah, see, this is why we do this stuff. So we got 9 minus 4 times 2 times negative. Make sure you use the negative symbol and not the subtraction symbol. 5. Okay. Now you can put those in parentheses too. I'm just going to show you that either way works. When you hit enter, that's what's underneath that radical. I'm going to write the square root of 49 right here. Okay. Now, real quick, I'm going to show you. Here's Here's the other way you could type that in. You could use parentheses. It just takes a second longer, but it might be a better idea to do with the negatives. You're going to get the same thing, 49. Okay? But use a calculator. There's no shame in that. Get that number under there right so we get the rest of this correct, okay? So what is the square root of 49? 7. You all okay with that? You don't have to worry about the positive negative because it's already in the quadratic formula. Now here's where the magic happens. Let's write x equals, I'm not going to make you write the whole quadratic formula again. You guys have it sitting up right there, right? Let's start filling this stuff out though. The first thing in the quadratic formula that goes right there is negative b. What would I put there then? Negative 3. Then there's a plus or minus, right? Okay, now here's why we did what we did. The next thing is that big radical thing, right? We already simplified it. We already said, hey, that becomes 7. Oops, I wanted to make that blue so you can tell where it came from. And if you want to like put an arrow like that's where it came from, you could do that just for this example. So if you think about it, had we been writing the quadratic formula every single time, we'd have written that 1, 2, 3. This has been the 4th line of us writing that entire quadratic formula over and over again. That's why I like to do that discriminant thing first. Now you just plop it in there. What goes in the denominator then? 2 times a, which is 2 times 2, which is going to be 4. Good. Okay, now you still have some simplifying to do here. Because 7 is a nice number that we can actually add and subtract, because of that thing right there, to the negative 3, we're going to go ahead and do that. So there's a couple of different ways you can handle this. I think the most organized, the easiest way to do it is to just rewrite this as 2 separate things. You could write them left and right. Oops. This one should be negative 3 minus 7 over 4. So I took care of that plus or minus by separating it. And now let's just find out what each of these are. In the numerator in this top one, negative 3 plus 7 is 4 over 4. What does that simplify to? Okay, 1. And then in this one is negative 3 minus 7. That's negative 10 over 4. Let's just leave this as a fraction. Let's simplify it though. What can that simplify to? Negative what? 5 over 2. Good. 5 halves, 5 over 2. Perfect. Those are your 2 answers. You can just circle them like that if you want. If you want to write something separate that says what x equals 1, negative 5 halves, that works too. But we got 2 answers there. Okay? Any questions on that at all? All right. Let us try example 2 here then. Okay, I'm just going to write it right here. A is 3, B is 8, C is 4. We're going to do the square root of b squared minus 4ac. I'm just going to write it right here real quick. You don't have to rewrite it because you have it up above. But so what's going to go first in that radical? What number should I put in there first? 64, right? That's b squared. B is 8. 8 squared is 64. Minus 4 times a times c. All right, let's just plug this in and see what we get here. So we got 64 minus 4 times 3 times 4. 16. So this becomes square root of 16. Square root of 16 is 4. I think we had that pop up before. All right, so let's put that into the quadratic formula now. Here's the quadratic formula. X is going to equal. All right, help me out again. What goes first here? Negative 8, negative b, so negative 8. Plus or minus now the 4 that we just found from before. Over 2a, be careful, 2a, don't just put a 2, it's 6. 2 times 3, right? 2 times 3. Okay, take a second, you separate those into 2 separate fractions and find out what our 2 answers are. All right, what do we end up with? Oh, I wrote mine wrong. Yeah, you're right. It is. I wrote it right in one spot and I wrote it wrong in another. There we go. Negative 2/3 and negative 2. Okay, we okay at that? I don't know. I've never really done like a scientific poll or anything to see if students like this way better, but I think it's less work. by doing this first and then just plopping it in. Um, I mean, if you want to rewrite that whole formula every single time, that's up to you, but I think this is a little bit more efficient.